All right, so what we're going to be looking at here is basically a way to organize our thoughts for doing a guess and check method. Now, basically what it is it's geared around this box, and so it's often called the box method of factoring. And so we're just going to start by showing how we can go forward through this process, which is expanding it. Then we can go backwards, which will be the factoring. So, if I'm going to be multiplying this out, I often could just kind of multiply everything in the first parentheses by everything in the second parentheses. And that's the way we normally would do it. But I want to give you a kind of a visual way of doing this. You might also recognize this as the same concept behind Punnett squares. If you've done those in science, then you know what I'm talking about. If you don't worry about it. It's intuitive enough. But basically, I'm just going to be multiplying the stuff on the outside to get whatever goes inside the box there. So like for this first box, I'm going to be doing 3x times 2x, which is 6x squared. Then I'm going to be doing 3x times 5, which is 15x. Next, I'm going to be doing the 2x times the negative 4, which is a negative 8x. And then I'm going to do the negative 4 times the 5, which is negative 20. All right, so if I actually want to multiply it out then, basically what I need to do is just combine the like terms of what I have in this box and write them all out as a single expression. So the 6x squared, it has no like terms, so it's just going to be 6x squared. The 15x, it does have a like term with the minus 8x. So I'm going to do 15x minus 8x, which is 7x. And then the minus 20 on the end, it doesn't have any like terms, so it stays a minus 20. Now, if I wanted to reverse engineer this then, and go from this expanded form, the standard form, into factored form, I could. And notice that the first two terms always multiply to give me that first box. So this is like the first term. So term 1. And then the last one here, the negative 20, is the last term. So what do the two in the middle mean? Well, you'll notice that our middle number adds to whatever those add to. So if I can make those two boxes add to this, then I could factor it. And that's going to be the basic idea behind this method of guess and check. All right, so now we're actually going to use this to factor it. So here's our problem that we're going to factor. Again, write it down. All right, and so remember that in the first box, I'm going to be putting the first term. And the last box, I'm going to be putting the last term. And so if the first term goes in the first box and the last term goes in the bottom right box, that means that I fill in the 11x squared first and the 6 goes last. The question before us is what goes around the outside. In order to figure that out, I need to now figure out what's going to add to the 35x there in the middle. All right, so now let's go ahead and actually start putting the pieces together for this. The easiest stuff to figure out is often something related to either the first or the last term. So like, what do I multiply by to get 11x squared? Yeah, to get 11x squared, that would be like 1 and 11 to get the 11. So that's the 1, that's the 11. And then to get the x squared, that would have to be x times x. So really we're going to be doing 11x times 1x. Now, you can write 1x, but of course it's a little bit cleaner to just write it as x. So that gives us our 11x squared. So already we know part of what this answer is because there's only just the one way to get the 11x squared. Now, you might be wondering, how do I know whether to put the 11 on the top or on the side? I didn't. There's nothing magical about where I chose to put that. You can put it in either place. It will just affect what ends up where on the next step. All right, now I look at how do I get the 6. Now remember how we get the 6. We get the 6 by multiplying those two. I got a couple options here. To get the 6, it could be 2 times 3, or it could be 1 times 6. Now, this is a guess and check kind of method. As you do a few of these, you'll get actually pretty good at the instincts and you'll be able to go through them faster. But I'm just going to make a guess right now. I'm going to make a guess of, let's say, 6. I'll do it a different color so we know it's a guess. And 1. All right, and so now I'm going to guess this. And so I can do this. I want to do this really light if I'm doing it on my paper so I can erase it if it's not right. I'll even sometimes draw the box in pen and then do the rest in pencil so I'm not erasing my box as I do the guessing. So that would give me 66x, and this would give me 1x if I multiply those each through like that. Do those two add to the 35x that I want? No. That would add to actually be giving me 67x. And so then I know it's not the 1 and the 6 like that. But if I switch the position of the 1 and the 6, it'll actually give me different numbers. So I'm now going to try switching the 1 and the 6 and see what that does. It'd help if I actually switched which one was where, though. There we go. All right, so now I'm going to try those. So if I plug those in, 6 times x is 6x, 11x times 1 is 11x. Do those add to 35x? No, they don't. That would add to 17x. All right, so that's not going to be it either. So I just tried both ways that I could use the 1 and the 6. So that tells me, since the only other way to get it is 2 and 3, it's got to be the 2 and the 3. It's just a matter of, is it going to be 2, 3 like that? Or is it going to be 3, 2 like that? Well, let's try one and find out. And basically it's an arbitrary choice at this point, but again, you'll get to where you can go to your answers pretty quickly. So I'm going to do 3 times x here, that's 3x. Then I'm going to do 11x times 2, which is 22x. If I add those together, do I get the 35x? No, I do not. That would give me 25x. And so that one does not work. All right. The nice part is that the only other possibility that could work here is just switching the position of the 2 and the 3. That gives me 2x. That gives me 33x. I do want to still check it. Does that add to 35x? Yes, it does. And so I wrote it the other way in the example. That's good. Okay, but it's the same thing. It actually still shows we get the same thing out of it. I then grab what they equal from the outside. So along the top, I see a positive x and a positive 3. So that is x plus 3. Down the side, on the outside, I see the 11x and the 2. They're both positive. And so inside the parentheses here, they are also both positive. It's just 11x plus 2. And that's our final answer. That is the factored form that we are going for. But notice it's really just a guess and check method. Now the last problem that we did, we actually did it the long way. Every single one of our guesses was wrong until the last time. What you're going to find with this one, though, is that that's not typically the case. We'll actually tend to go through these pretty quickly. And so I, again, am going to go ahead and use the box to help visualize what this is. There's nothing magical about the box. You could actually do this longhand, which some people will do. Some of you will look at it and you'll say, well, I'm guessing that it will start with a 17x and an x because that's the only way to get 17. And there's only one way to get 23, and that's 23 and 1. So it's either going to be 23 and 1 or it's going to be 1 and 23. And I'm going to have to try out which one it is. And that's fine if you do it that way. That's just the root of guess and check. This box is just a way to help visualize what's going on in the guess and check process. All right, so using our box here, the first term always goes in the first box. The last term always goes in the last box. Now notice the 23 is a negative 23. All right, so for the 17x squared, well, really the only way to get that is 17x and x. And again, there's nothing magical about which side I put the 17 on. I just need one of them to be 17 and one of them to be 1. And it's nice this way because the 17 is a prime number. It makes our life a lot easier. And 23 also being prime, it's really just a question of where I want the 23. Now, as you look at these, you're going to develop some instincts. And one of the instincts you might notice is that I'm adding to a really big number here. If I'm going to have a really big number involved, that probably means I'm going to have to be multiplying the 17 by the 23. So I'm going to start by guessing the 23 to be up there. So I'm going to put the 23 here, and I'm going to put the 1 for 1 times 23 there. Now, it is a negative 23. So one of these is going to have to be negative, and only one of them. But I'm going to do that multiplication first before I decide which one is going to be negative. So the first thing I do is 17 times 23. That gives me 391, and there is an x there, so it's 391x. And then the x times 1 is just 1x. Now remember, these two need to add to 390x. But one of them needs to be negative. Well, in order for them to add to a positive 390, that means I want the 391 to be positive, and I want this x to be negative. Well, if that x is going to be negative, then the 1 has to be negative. And now I have my factored form. If I read across the top, I see an x and a positive 23. And if I read down the left-hand side, I have a 17x, and I have a negative 1. And there's my factored form. All right, so for working this one through, I start by putting the first term in the first box, the last term in the last box, and then it's a matter of thinking about what can I multiply to get those. The easiest of these is the 1. Of course, in order to multiply to 1, it always has to be 1 times 1. Now, one of them will have to be negative. I'll decide in a minute which one I want to make negative when I actually try to add those other two. Now, to get 221, that one may not be one you know off the top of your head. So you break out your calculator and you try to figure out, okay, what multiplies give me 221? And you try a bunch of stuff, and eventually, at least hopefully, you would find that 221 is made by doing 13x times 17x. Now notice, both 13 and 17 are prime numbers. So the only way that this is going to work is either going to be doing 13 and 17 or 221 and 1. But 221 times 1 is a lot less likely, so I'm starting with the 13 and 17. Now, I try multiplying those through. So that gives me 17x. This gives me 13x. It looks like I can make those 4 apart. I want it to be a negative 4. Remember, I'm going to have to be getting the negative 1, so one of these has to be negative. And it looks to me like I'm going to have to make the 17 negative because I need to have more negatives than positives. And if these are negative, then so does that one on the outside need to be. And now we have our factored form. Reading across the top, it's 13x minus 1. And reading down the side, it's 17x plus 1.